A lot of great talks ahead of this. The instructor one made me immediately. I've been in my text editor writing an instructor Ash extension for the last hour because I was like, okay, we should have something like that too. Um, so yeah, let me go ahead and pull up my presentation here. Ultimately, what I've landed on is I'm actually just going to sort of give a very similar presentation to what I gave at ElixirConf EU. And the primary reason for that is that uh, we've refined that a lot, and it was a lot of folks were pleased with it and kind of said, hey, you finally managed to explain what you're trying to explain, which is a good thing to hear. So I'm going to go ahead and dive right in. So Ash Framework is a resource-oriented declarative design application framework. And the application framework bit is important, where if you've worked with Phoenix and you've worked with Phoenix contexts, generally speaking, they don't have any opinions on how you build your application. It's done via, define your own modules and functions, which is I think it's a great opinion for a web framework to have. But in contrast to that, Ash Framework is an application design framework. So that's kind of people, you can use these things together, and almost everybody who's using Ash is also using Phoenix. So it's not a competition, or we're not in competition. I think quite the opposite is very complementary technologies. So the community is growing, which I think has been a lot because of the decisions we made recently moving to Elixir Forum to have people go, do support through the Elixir Forum. You can see we've got a lot of posts coming through, and we've got our own fancy section now because Aston we had enough traffic that warranted getting this little custom forum section. So that's been nice. We also have a Prog book coming. Rebecca Lee is doing a lot of amazing work. Most of the work, I want to make that clear. I've been doing a lot of advisory and sort of writing with some of the super technical finicky bits. But Rebecca's really killing it. Her writing style is amazing, and I'm really quite excited for you guys to see what that looks like. So that should be out sometime soonish. These things take a long time, but we are actually well underway. So that's nice. So I'm going to start with a story of a function. And this is just to show kind of how our applications tend to grow over time. So this is a baby function. It's beautiful. It's simple, right? Everybody knows what this does. This returns to us all of our tweets. And it's very easy to understand. So this is a toddler function. It's honestly, it's still simple, right? If you look at this, you're not going to be like, oh my gosh, that's so complicated. I don't know what to do. However, I would say that this is headed towards a troubled childhood. So again, these problems are beginning to sort of seep in, and you'll see what I mean here, which is this is an adolescent function. Again, it's unpleasant. It's a handful. It's not the worst thing I've ever seen, right? But you can see this has a lot of opinions. It talks back to its parents, right? So it has these ideas of how you're meant to use it. This stats option is kind of like a weird flag that will bring in some additional fields. And ultimately, this is kind of like the middle adolescent phase of a lot of our functions that we construct our business logic with. Okay, so this is a grown-up function. It's cleaned itself up. I would suggest that although it's nice, its potential has been wasted. And there are millions of functions like this out there. I see them all the time. Our applications consist of these kinds of functions, right? Especially if you're building like your classic SaaS product, right? You just have these sorts of things all over the place. And this actually isn't bad, right? So I'm a consultant in my day job. And if I see this, I'm not like, oh gosh, no, throw it all out, let's start over or anything like that. However, I think that we can do better. And that's a lot of the work behind Ash Framework. So let's clarify some terms here, because I use the word declarative a lot in the description of Ash Framework. And I'm just going to use imperative as a sort of contrasting term to declarative. So imperative is, most things that aren't declarative is a better way to think of it. But in these design patterns, an imperative, you might focus on code, whereas on declarative patterns, you focus on data. You might focus on individual instructions with imperative patterns, whereas with the declarative design, you might focus on the end result. So an example here is, telling your child, pick up your toys, put your laundry in the hamper, make the bed, or telling them that your room better be clean when I get home or there will be hell to pay, right? So you're not telling them exactly what to do. You're telling them that the room needs to be clean. And an interesting part about this is like this piece of advice isn't like you should use declarative design doesn't mean a lot on its own. It only works when you have a smart tool, right? So this example, we're not telling your child to pick up your toys, not telling them to put their laundry in the hamper. It only works if they already know how to clean their room. Like you have to have already told them before, they have to understand this concept. But you can't just say that the first time, right? Like you can't say clean your room if they don't understand what constitutes a clean room. So declarative design requires smart tools. And I think a good example of that is SQL, actually, right? So the SQL planner, the SQL optimizer, all that sort of stuff, really smart tool. And that's what allows us to have a declarative language that sits on top of querying data. So another important factor here is that imperative and declarative is relative. And this is maybe debatable. However, you've seen this over time historically that people call things declarative. It's relative to how much you have to tell the computer what you need versus how much you used to have to tell the computer what you need. So in 20 years, the stuff I'm talking about is going to feel imperative in a way because I have to give the computer so much detail compared to, I don't know, an LLM or something like that in the future. I don't really know. But so looking at this example, right, on the left, we're explaining how you go from the beginning to the end of a list. We're saying you start at 0, you increment a variable until it's the length of that list, and then you get that value out of the index like that. Whereas in this declarative example on the right, we just say for each item in the list, do this thing. We don't explain how to go from from the beginning to the end of the list. Using an example from Ash, we have policies on the right. Here's an example of doing it imperatively. This authorized access function, given an ecto query and a user, perhaps if they're deactivated, we want to say, no, you can't do that. If they're a super admin, we want to let them query whatever they want. And if they're a normal active user, we might say, okay, let's only show them published content. And if you look on the right, this is the same sort of thing. It's the same sort of workflow, which is, if they're deactivated, then it's forbidden. If they're a super admin, then they can see whatever they want. Otherwise, only show them things that are published. But there is I think an important difference here. So these policies are data. This is a sort of post-translation step a little bit here, right? But we actually turned this into a Boolean statement. And each one of these is a little behavior that tells us about, that tells us how, the properties of this check. And at some point it turns into this, which is a little wacky, but we use what's called a Boolean satisfiability solver under the hood. And that satisfiability solver accepts statements in this format. But the thing is, like, this is there's a little bit more metadata here that I'm obviously hiding for the sake of presentation, but this is actually what we pass into the solver. And you can't turn the code we were looking at in a couple slides ago into a solvable, you can't reliably turn it into a data structure that can be solved by a solver, right? It does one thing and one thing only, and it does it in exactly the order that you said, which, sometimes is nice, but other times it's a very limiting design pattern. So that leads us to this concept of artificial constraints. And I would say that imperative code imposes artificial constraints. And this exists all over the place. There's a lot of times where you realize, like, the way that I've written code, the way that I've written this has limited me. And once you see it, you can't unsee it. Once you understand that had you written it in a more declarative or more, data-oriented way, that those same limitations would not be present, or that you would be free to pivot the implementation on top, without having to change the declaration. And once you start seeing that, it's you can't unsee it. So let's talk about some of these constraints that we deal with. Order matters. Here we go. So given this, like, these are two computed fields. These are functions that take a tweet and add some computed property to it, right? Let's just say that some computed field 2 has a dependency on some computed field right? You can't just swap the order that they get calculated in. If you ever see some computed field 2, it must come after a call to some computed field, right? Which is, I would suggest, is a flaw that can be fixed in multiple ways, right? These are design problems that you can fix just with code. But ultimately, the way that we've implemented this means that we have to say it in the right order, and that's not a property of the that doesn't have to be true for writing something that can compute data. A great example is an Excel spreadsheet, right? You don't have to tell the Excel spreadsheet what order to evaluate your cells in, right? It solves that problem for you. Okay, simple or optimized, pick one. This is a really classic thing that we see all the time. Just as, doing regular day-to-day engineering, which is, you say this to yourself while you're writing code. This could be faster, but like it's going to be way more complicated if I do that. And so we often make the correct choice to go for the simple implementation over like the theoretically fastest implementation or most performant implementation. But the fact that you often have to choose that can actually be factored away sometimes, right? There are ways, declarative patterns, to get both the simple and the optimized solution. So this particular issue is we join to the user table twice. We have this tweet query, and we want to get it when it's for the active users, and we want to get it where it's from one of my friends, and we want those two. My presentation thinks I'm giving you a thumbs up. Anyway, so we want it to be able to those functions to be used independently for active users and from friends of. But when you combine them, you make two joins to the users table. And the truth is that's not a big deal, right? Like it's simple. I'm sure your users table has an index on it for this particular case. It probably doesn't matter. And the solution is not worth it, right? So the solution is to make these sort of smart joiners. And we do this. I mean, I don't, but this is the sort of thing that you would do to optimize these issues, which is you would use named bindings for each join. And then you would say, well, hey, have I already done a join to friend link? And it's like, okay, I haven't. So now I can join to it. Same thing. Have I, joined something called user? And this technically works. You've got an optimized version of the same thing that doesn't join to users twice. Is it worth it? Probably not. And you also, what emerges from this is a different kind of problem, which is what I call accidental languages. So we've built in a bunch of semantics to this thing, what effectively amounts to like an optimization language, where we have this thing called friend link, and we expect friend link to be a certain thing. Like you can't join something else and call it friend link and not have a problem, right? Like it's a sort of locked in place concept, what a friend link is. And that's the same with this user name that we have throughout here. These are terms in an accidental language. And I'm not against, in fact, I'm very pro the idea of designing a language for solving a problem, as you'll see, right? If you're familiar with Dash at all, I'm a big proponent of that sort of thing. But it should not be done on accident. It should be an intentional process. So let's change gears a little bit and talk about extensibility. Let's say we have this sort of classic example of like a Phoenix context here, where we've got these operations defined as functions, and somebody comes to us from the business side and they say, hey, we need to send data about user events to our analytics platform or to some monitoring solution or whatever. Your options, like how do you extend all of these operations to do this thing? With this design, you have to put code in all three of these places, right? You could theoretically do it by modifying your repo, but that's a bad idea for its own reasons, right? You would put code here, and maybe that code is generic, like it's code that says like send analytics event, and then you look at what happened to figure out what the name of the event is or something like that. But you still ultimately have to go and modify all of these pieces of code. So they're fences in a way, what you'd call like an optimization fence, or in this case, an extensibility fence. Another thing that happens is we get these single-use functions, even though there are multiple ways to express the same concept, right? So in this case, we have you have a full name calculation. Again, these are just simple examples because these aren't how names work in real life. But here we compute the full name in Elixir with this full name function, but then we need to be able to, maybe we have a search bar that filters by full name, right? So we have to put that into our SQL query if we want them to be able to search by full name. This fragment here is the same thing as this, conceptually speaking. It's just a different implementation of the concept. And, you can do things like, you can add make a macro called full name just to illustrate that they're the same, but you still face the risks of implementation drift. And you still, the more you sort of, if you want to add, okay, well, how do I express the full name in this other context or in this other data layer, you're sort of back to square one. So this isn't really a solution to the problem, even though it does make it better. So yeah, functions can be used for one thing and one thing only. We also have a problem of limited composability. You can compose functions, right? But in very strict ways. So let's take these for active users functions and this from friends of function and say, well, I want to be able to give, say, or either they're from an active user or they're from one of my friends. So maybe we would make this function here, this or for friends of. And we're saying, okay, now we can pipe into or for friends of, where it has this or where instead of just a regular where. And there's a problem here, right? There is a bug in this. There's a pretty subtle bug, which is that this technically needs to be a left join. Otherwise, you think it's not just or where, it's also where they have any friend at all, because you're inner joining on the friends table, even if you aren't attaching a filter, right? So it becomes quite difficult, actually, and difficult in subtle ways to compose these sorts of things, because they actually have to be aware of how they're being composed. Like, you can't just pipe that into or where, or say like, or these two things together. Their implementation must be fundamentally different on the inside in order to compose in certain ways. So these are the kinds of things that we aim to solve with Ash Framework. We're going to go back through the problems that we discussed, and I'm going to show you some examples. So we have our order matters here for sort of computed properties. In Ash, we can infer the order that these things must go through. And you're going to see some examples of calculations in a minute, but here you can see, like, we just say load some computed field and load some computed field too. And we've expressed in the calculation definition that some computed field 2 depends on some computed field 1. So you don't have to know that. It just happens. Simple or optimized. So you saw what we had to do to optimize this, but in Ash Framework, we would do this differently. So we would define calculations that map to these concepts of, for active user and from a friend. And we use these expressions here, which you'll see a couple examples of, but expressions are a data agnostic, a data layer agnostic expression. And so we don't actually provide like a procedural instruction to join. We don't say join to users, right? We provide a truth statement that the user for this thing is active, or that there is a friend link where the friend ID is this user's ID, that sort of thing. And then we compose those like this. We say where for active user and from friend of, and under the hood, the logic for doing this filter ensures that you've joined the minimal amount of times. It will use an inner join when it can, or a left join when it has to, right? And you'll see more about that in a bit, but this is an example of how I don't think that this is any less complicated. I think it's, or any more complicated, I mean, than this example. In fact, I think it's, a lot less complicated, because you don't have to see all of these instructions about how to join. And instead you just have the definition of, these as truth statements. And then you can use them in your filters. So we didn't have to trade simple and fast or optimized. And yeah, only joins the users once. So now let's talk about the accidental languages. We're going to go right back to the code we just looked, because we actually design these languages, right? We make these tokens, this for active user and this from friend, which again map to some statement, and we use them intentionally, right? We don't let these things sort of accidentally emerge. They become part of the language of our resource. This is, again, part of a resource. We're not going to dive too deep into exactly how resources work. There's getting started guides and all sorts of stuff that if you really want to, you can go through those. But this is where we favor actually design the language of your application. So close to extensibility. Adding cross-cutting concerns is kind of not possible with functions. You have to do it yourself. You have to put code in every single one of your operations. But with Ash, because these are what we call actions. These are one of the core things in Ash. They aren't just functions. They are data, which means that we can modify them. We can pop them open and add something to each action, and that's what this does. We had this thing called changes. Think of it like a plug, but for a change set. This global changes block actually happens for all of these actions. And you can also take that change and put it inside a single action if you wanted, for example, to only track an analytics event on specific actions, or if you felt that this was too unclear, that like putting this in a separate area could lead to confusion. But what's nice about that is you don't have to design it with that in mind. Like you make this change called track analytics event, and then you can decide where you want to put it and how you want to put it, but you get to opt into this amount of extensibility without having to change the operations if you don't want to. So we can talk about these single-use functions, and this is going to go back to the calculations example. But in Ash, we have a calculation using our data layer agnostic expressions. And so what that means is you might say, filter by full name, and this will be translated to Postgres or to SQL. But you can also calculate in memory. Given like a first name and a last name, you can say, give me the full name. And this is just one small example of how you might do that. This exists sort of all over, but sorry, not next slide. So Ash will do this for you. You have to do certain, give it some certain options. It's like, am I allowed to reuse values in memory? Because sometimes you'd like, no, I want you to fetch the stuff from the database. But Ash will actually use this property of expressions intelligently. So limited composability, this also goes back to calculations, but in this case, we noticed that it was difficult to, you can't really compose these things with an or without giving fully different implementations. But given these calculations, they are composable by design because you aren't giving me imperative joins, you're giving me truth statements. What this means is I can AND them together, just like the original example. I can OR them together. And what's actually quite interesting is like this one will do an inner join. This one will do a left join. Actually, no, this one will do an inner join too because they both have to join to users. But this will do a left join on the friend links because it knows that this one doesn't join to friend links to be true. And therefore, an inner join would not be the same logical statement. But we can also do things like this. This is a valid expression, which is we can say, if it's for the active user, then it should be from one of their friends. If it's not for the active user, then it should not be from one of their friends. I mean, this is a weird filter to write, but you can write it. And this will turn into a case statement in the database, which I thought I had an example of, but I don't. But this is a way that you can compose these even in ways you wouldn't have thought of before, right? You're not just anding and oring them, right? You're using these computations anywhere in an expression. So you can use these in policies. So you can see we have this, if they're an active user, then you can only see this tweet if you're one of their friends. You can use these in atomic update statements. So these are statements like update increment, like score +1 is an atomic update, right? Here's an example where we say, okay, set the status to published if it's for an active user or to pending if it's not. And this will be translated into the update statement that we make to the database. So this dovetails into atomics and bulk actions. So in the past, I've tried to go wide. I want to show everybody, look at all the cool things that we can do with Ash. But what I've found actually is that this is a better strategy is sometimes to say, look at the natural conclusion of these design patterns when we push all the way through. And atomics and bulk actions are a great place to talk about that. So here's an update action with a change in it that sets the attribute published to true. You can use this by saying ash.changeset.forUpdate, right? And then you can call update. This is a very you've seen this sort of pattern with Ecto where you might say cast, the inputs, and then, it's a little bit more action oriented in Ash, but it's a very similar concept. And then we have this question of what if I want to publish many posts? And I'm sure you've all been through the process of like, okay, well, I can't just insert a change set anymore, or I can't just update with this change set. I need to use like an update all. And then I need to rewrite the things that I'm updating to be like an expression, like using the Ecto query syntax. And our goal with Ash is to give you this data. You define your action, and for us to be able to do that transformation for you. So what that means is that we have to be able to turn this bit into an expression, this set attribute published true. To understand how we do that, you have to know what this is. Surprise, it's data, right? So that's not like a function that is doing things. It's just data. It's a convenient name for data, but this returns a module with some options, very similar to a plug. So in this module, it can tell us, here's how to do this operation against a change set in memory. This is very useful, even though, you know, the atomic is like the, maybe you might say more correct one or the more concurrency safe one. This is really useful for things like forms or for in-memory validation, all that sort of stuff. But we can also enhance these to support being done atomically. And so in this case, the atomic is very simple. It just sets the given attribute to the given value. But this would be a concurrency safe operation. So if we look at this and we say, make a query over post for the current user and publish, this will translate that into a single, sort of the equivalent of an update all query. It'll say update all the posts, set the status equals published, where it meets this filter, which I would actually say isn't that impressive yet, right? Just this is not a significant win over other options. But this is where we get into extending this pattern to support all of the things that Ash supports. So let's take a look at a validation, right? We say the score has to, this is on a games resource where, you know, maybe whenever you do something, you get an additional point. And you say, actually, the score needs to be less than 100. And this will be translated into a SQL statement. Like we can do this sort of like, imagine you've got two people and they're incrementing the score concurrently with each other. And if the score ever goes to 100, that is an error. But you can't only rely on your in-memory data unless you want to lock. You can't rely on the fact that, like, maybe I say 98 and then I issue a SQL statement, you know, to add 1 and it becomes 101 and my in-memory validation doesn't work. So this is actually a significant problem for a lot of applications, especially Elixir applications, which are so concurrency focused. And you don't want to lock this game. You shouldn't really have to, is for these kinds of things. So we can actually lower that, all of your validations, all that sort of stuff into the database for concurrency, safety, and performance. And another bit here is that we have policies. Ash has a sort of solution for authorization, and you can write your own authorizers, but the built-in policy authorizer is very powerful on its own. I don't know of anybody who's opted to write their own authorizer as opposed to use that. But as with everything in Ash, these authorization policies have to always be applied no matter what the context is around this operation, right? So sometimes you can write your policies in a way that we can't do them atomically, and we'll tell you like, hey, you can't do this atomically. But there isn't a case where we just don't apply them because you're doing something atomic or anything. Like, you know, either it's going to be safe or atomic and you'll know that everything's being applied, or it won't be atomic and we'll tell you why. So what that means is we have to be able to turn these policies also into SQL queries or into expressions. And so if you look at that, we actually do this. So we can say, well, if the current score is 99 and the next score would be 100, you know, or let's say you're not allowed to, the policy in here is that you're not allowed to change the score from 99 to 100, right? So here we say, well, if you're changing the score from 99 and the next score is 100, then it's a forbidden error. However, if you're changing the score to 100 at all, then it's an invalid error. Now, these are actually sort of mutually incompatible statements because you can only increment the score by 1, but that's not important. But if you also look, we have this policy over reads right here that says you can only see one of these if you are one of the players in the game, and that's also applied in the exist statement here. So what that means is you have all of these concepts that you've leveraged, that you've been writing declaratively, like your policies and your validations and your changes and your updates, all that sort of stuff, right? And Ash can translate all of them into a single atomic statement, which allows you to have, again, concurrency, safety, and performance. And that means that this operation, these 5 lines of code, are extremely powerful. I guess 1 line of code, it depends on who you ask. But they're extremely, extremely powerful because this is now safe to do. Given a current user, I can say, increment the score of all of my games. And what this means is, for all the games that I can see, increment the score unless I've done something that is not valid, in which case show a validation error. And that's really powerful because you don't need to all of a sudden, there's all these structures you don't need anymore. There's locking, there's, you know, statefulness, to handle like, okay, I've locked and I have this thing now, and now with this thing I'm going to increment, and like, no, just model the operation declaratively, and we'll figure out how to do all that for you. So to show a real life example of this, because these atomics are relatively new and we're extending them throughout our ecosystem, there's a package called Ash State Machine, and what that does is it lets you turn a record or a resource into a state machine. So for example, this is like a package. Every time you send a package, you might store a package resource, and it's like it starts off as pending, and then the post office says. The post office says like, okay, we've received it, and then the customer will say it's arrived, and so the state machine models those transitions. But how do we make this transition state atomic, right? It's not just set the state to something, right? It's make a valid state transition. This is very important. You can't just say set it to pending unless its state was, or well, I guess in this transition state should say confirmed. But you can't set it to confirmed unless it's in the appropriate state already. And if you have to be using the appropriate operation to do so. So we actually do that. The transition state is a provided change by the Ash state machine. And I've omitted some stuff. It's not really important, but we can translate this requirement of what is a valid state transition and what states are allowed to go to and from into an expression directly, and we can return a validation error as a result of that. And what this means is all of a sudden you can now say, you can have like a confirm all packages button on the user's, you have your live view or something, and they've got 5 packages, and you can say like approved, they've all arrived, and you can use this to set them all to arrived. And you could filter theoretically if you wanted, you could say filter where they're in the state of on their way or whatever. But ultimately that's safe to do. It's going to follow the authorization rules, and it's going to be done in a single query. And in the words of one of our users, thinking about this, it makes me realize it's quite amazing. I would never have taken the time to make such an action atomic with just ecto. I maybe would have locked if it were very important, but now it's just a drop in, don't think about it feature. And this is an example of the sort of thing that you get with Ash all over the place, which is we give you a declarative tool, and then we actually implement things that are hard to implement in the specific. But because we've implemented them in the generic, it's actually quite easy for me to say, oh, well, how do I do that atomically? Here's the expression. And now you have bulk, safe for bulk operation, safe for authorization, concurrency safe, atomic actions that can be taken across, even things like your state machines, which have complex validation rules and may have their own policies and all that sort of stuff. So that's the end. I think that's a good example of where we're going, but there's tons of other features in the Ash ecosystem. So, if I've piqued your interest, take a look. We've got a lot going on, a lot of neat stuff.